You have spent months mastering data structures, working through algorithms, understanding time and space complexities, and practicing countless problems for your dream job at your dream company. The big day arrives. 10 minutes before the interview, you are sitting quietly, nerves kicking in, heart pounding, trying to calm yourself. Then it starts a quick intro, and the interviewer pastes the question. What's your playbook? What steps can you follow to maximize your chances of performing well? Welcome back to Depth First. Today, we will go over a step by step playbook to confidently approach and solve coding interview questions. The interview question you will be asked will most likely fall into one of the three categories. First, you have seen this question before, maybe on LeetCode or maybe in a mock interview. You already know the approach. Second, you haven't seen this exact question, but you have a good instinct of what data structure or algorithm could work. Like, this could be a heap problem, or I think DFS would be useful here. And third, you have no idea how to solve it. It feels hard, unfamiliar, and you are unsure where to even begin. No matter which of these three buckets your question falls into, this playbook can help you navigate it with just a few small tweaks depending on the situation. The first step is to thoroughly understand the question. Before you write a single line of code, make sure you fully understand the problem. Don't hesitate to read the question out loud. That is fair game and often a great way to catch details you might miss otherwise. It is tempting to jump straight into coding, especially if you have seen a similar question before. But sometimes there is a small twist that changes everything. For example, this is a very popular interview question where, given an array of integers nums and an integer k, you need to return the total number of subarrays whose sum equals to k. However, a twist to this question could be to return true if there exists one subarray whose sum equals to k. A small change like this can shift your entire approach. This is the part you don't want to miss. Always pause and validate your understanding of the problem. Then make sure your interviewer is also convinced that you have understood the question completely, including all its nuances. To make sure you truly understand the question, try these two things. Ask clarifying questions. Create a few test cases to validate your understanding. Let's cover these in some more detail. Asking clarifying questions help uncover hidden details and shows the interviewer that you are thinking critically. The goal is to scope out the problem. It also opens up a two-way line of communication. You can ask any number of questions to better understand the problem, but here are a few examples focused on clarifying what the input contains. For example, if the input is a string, ask whether it can contain uppercase letters, lowercase, or spaces. If it's an array, check whether it's sorted, can it contain duplicates, or if it's really large. If it's a linked list, confirm whether it's a singly or a doubly linked list. If it's a graph, ask how the input will be given as an adjacency list, adjacency matrix, or maybe just a root node. Your interviewer may or may not provide test cases, but you should always come up with your own, especially to validate edge cases. Start simple. For example, if the input contains a string, try an empty string or a string with a single character. If it's a linked list, so maybe a null list or a list with just one node. If it's an array, try an empty array or an array with just one element. These are just examples, but the idea is to cover both the normal and the edge cases. And when you explain to them, be clear. If this is the input, here is what the output should be. If you already have an approach or an algorithm in mind, this step gives you valuable time to solidify that approach while walking through your test cases. It is like buying yourself thinking time without an awkward silence. This not only shows that you're being thorough, but also signals to the interviewer that you are thinking about the correctness right from the start. The next step is to come up with the algorithm. If your question falls into the first two buckets, like maybe you have seen it before or you haven't, but you know the data structure or algorithm that fits, lay out the approach with your interviewer. Walk them through your thought process and explain your execution plan. Cover the time and space complexity, and if you've got multiple options, highlight the trade-offs. Once you are aligned with your interviewer, then move on to coding. Now, let's talk about the third bucket where you have no clue as to how to solve the question. You have never seen anything like it, no obvious patterns, no clear algorithm or gut instinct kicking in. First of all, don't panic and definitely don't give up. Pause, breathe, and think. Think real hard and apply yourself. Ask yourself, is there a pattern I vaguely remember? Is there a data structure that might fit? What would a brute force solution look like even if it's slow? Now let's say it has been 10 minutes and you still haven't cracked it. Your interviewer might say something like, maybe start coding because we are already 10 minutes in. My recommendation would be to not start coding until you have a clear plan. Instead, try this. Ask for a small hint. Something like, I'm torn between two directions. Could you let me know if I'm thinking in the right direction? Ask another clarifying question. We humans have a lot of basic intelligence and intuition to solve problems, even without a computer. So pause and observe the process. Ask yourself, how would I solve this manually, step by step, without a computer? Trust that instinct and use it to come up with a brute force approach. Even if it's not the most efficient solution, it still highlights your problem solving skills, which is one of the key axes interviewers are evaluating you on. The last step is to dry run and validate the code. Once you have coded up the solution, it is critical to validate that it actually works as expected. At some big tech interviews, you are expected to do a manual step-by-step dry run of your code to ensure correctness. In other cases, the interviewer might already have a set of test cases prepared. You'll need to run your code against those, and it is expected that all of them pass. If a test case fails, you are responsible for identifying and fixing the issue. In both cases, manual debugging is the key part of the process. Let's go through an example to illustrate that. We'll go back to the question that was pasted by the interviewer in the earlier slide. Given an integer array nums and an integer k, return the k most frequent elements. You may return the answer in any order. This is the test case we are using, and the output is 1 and 2 since these are the most frequent elements. Here is the solution we've implemented. To begin the dry run, we need to track all the variables that are being used in the solution. So in this case, that would be heap and counter. So we'll now become a human debugger, stepping through the code and observing how these variables change at each step. First, we'll initialize the counter. Now we'll step into the loop. We look at the first key value pay in the counter, that is 1 with a count of 3. So we push 3 and 1 into the heap. Since the heap size is still within k, we move on. Next, we push 2 and 2. Remember, this is a min heap, so the element with the smallest count, in this case 2 and 2, bubbles to the top. Heap size is still at 2, so again we skip the popping step. Now we push 1 and 4 into the heap. The element with the smallest frequency, which is 1 and 4, moves to the top. At this point, the heap size becomes 3, which is more than k. So we pop the smallest element and that takes out the tuple containing 1 and 4. The heap is now back to size 2. We have completed enumerating through all the elements of the counter hash map. Finally, we return the top two numbers with the maximum frequency, which is 1 and 2. The idea is to become a human debugger. Walk through the code line by line and track how the variables change, just like you would on a whiteboard. It is one of the best ways to catch bugs and prove your logic is solid. A lot of people either just dry run verbally or are all over the place when writing out the variables and stepping through, so that is something that you want to avoid. Thank you so much for watching. I wish you all the very best in your upcoming interviews. If this video has helped you, don't forget to like, subscribe, and share it with your friends to support the channel. And if you have any feedback, I would love to hear it. Just drop a comment below. Goodbye.